Hello students, I am Vijay Kumar Patel, PGT Chemistry, JNV Golaghat, Assam. Present again with a new topic for class 12, first unit solid state. Today's topic will be packing efficiency of solids. Packing efficiency, it means in a cube, we have studied in my previous video, there are three types of cells: body centered cell, primitive cell and face centered cell. And we have also calculated total number of atoms in three different types of cells. In primitive cell there are only one atom. In body centered there are two atoms. In face centered there are four atoms. So if in a cube 1, 2, 3, 4 or so on atoms are present, then packing efficiency means the space of this cube. Okay, so how much of the space of cube is occupied by atoms, or simply we can say how much volume of cube is consumed. It is known as packing efficiency. Formula of packing efficiency, it is number of atoms in unit cell into volume of an atom into 100 divided by total volume of unit cell. Simple. So let's see first primitive cubic cell or simple cell. To calculate the packing efficiency, we will see first the picture. In this picture you can see very clearly that here this is a cube, and this cube, definition of simple cube, it is when the atoms are present only at corners. One corner, two corners, 3, 4, 5, 6, 7, total 8 corners are there. So 8 atoms, 1, 2, 3, 4, 5, 6, 7, 8. 8 atoms will be present in corners. So these are atoms which are present at corners. The radius of these atoms, it is R. Radius of this atom is R, and the age of this cube is A. This A is age and this R is radius of atom. So let's see. Let the age of the unit cell is A and radius of an atom is R. Then from figure it is clear that age AE, this is equal to double of radius. So simple, A, it is equal to 2R. Hence volume of cubic cell, we know volume of cube is A cube, and the value of A, it is 2R. So this will be 2R cube, total is 8R cube. This is the volume of cubic cell or unit cell. Volume of an atom, since atoms are spherical in shape, so the volume of sphere, we all know it is 4 by 3 pi r cube. So packing efficiency, put the values in this formula. Number of unit cell, number of atoms in unit cell, since it is primitive, and in primitive number of atoms are 1. So number of atoms in unit cell, it is 1. Volume of an atom, 4 by 3 pi r cube into 100 divided by total volume of unit cell. So the total volume is 8R cube. Put this value in this formula and calculate, it is 52.4%. It means 52.4% volume of cube is occupied by atoms in primitive cubic cell. So here the key point is packing efficiency of simple cubic cell or primitive cubic cell, it is 52.4. Let's calculate packing efficiency in face centered cubic cell. Formula is same. Let's first see this cube. In this cube, these are sides, 3 atoms. The position of these 3 atoms, it is very, very important, because the definition of face centered cubic cell is when the atoms are present at corners. So corner, 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 corner. Atoms are present at corners as well as at the center of the face. So the face A, B, C, D, its center is this one. Here this atom is present. So atoms are present at corners as well as center. Join A and C for our calculation. The radius of atom is R and the age of cube is A. So in triangle ADC, here ADC, in this triangle, you see this is a right angle. Okay, so if it is right angle, this one is perpendicular, this one is perpendicular, this one is hypotenuse, and this one is base. So we know, according to Pythagoras theorem, AC square, this AC square, which will be equal to AD square plus CD square. So AC square is equal to AD square plus CD square. This is the formula. Value of AC. This AC, name this line as B. Suppose the length of AC is B. So AC, it should be B square. AD is the age of cube. So this is A. So AD square will be A square. CD square will be A square. So B square is equal to A square plus A square. It is B square is equal to 2A square, or B it is equal to under root 2A. This one is under root 2A. This is a length of AC. Okay, this is the length of AC. But we know that B is equal to 4R. B means what? B means AC. This B is equal to 4R. Why 4R? Because here see, this one is radius, this one is twice of radius, it's a diameter, means twice of radius, it's a radius. So 1, 2, 3, 4. 4 times of radius is equal to AC, or AC it is B. So B is equal to 4R. So now we have two equations. B is equal to under root 2A, B is equal to 4R. So compare these two equations. We see here under root 2A it is equal to 4R, or A it is equal to 2 under root 2R. So this is the value of A. A means what? A means age of cube. So now packing efficiency, total number of atoms in unit cell, it's a FCC. In my previous video, you understood that short trick to remember the number of atoms in FCC. F means face centered, FCC, F means 4. So the total number of atoms in unit cell, it is 4. Into volume of an atom, radius of atom is R. So the volume will be 4 by 3 pi r cube into 100 divided by total volume of unit cell. Volume of unit cell, it is A cube, and A is equal to 2 under root 2R. So the volume of unit cell will be 2 under root 2R cube. If you solve this, you will find 74%. It means 74% volume or space of cube is occupied by 4 atoms in face-centered cubic cell. So the key point to remember is packing efficiency of FCC, it is 74%. Now let's see packing efficiency in body-centered cell. Before we start calculation, first understand this figure. Here this is a cube. In this cube, join the diagonals F and D. It's a diagon, okay? And join F and A. This is a cube diagon. Remember, this one is a square diagon because this face is square shaped. So this is a square diagon. This is a cube. So it's a cube diagon. Okay? F and A. Remember, diagon of F, it is B. This is a square diagon. But if you join F and A, it is cube diagon. So, to calculate cube diagon, let's start calculation in triangle EFD. Where is this? EFD. EF, it's a age is equal to A, and FD, it's a diagon, its value is suppose B, and the value of AF, cube diagon, it is C. So in EFD, you can see very clearly, FD square, it's a hypotenuse, so FD square will be equal to EF square plus ED square. A square plus A square, it is equal to B square. Here, this is the formula. B square is equal to A square plus A square. Then B square, it is equal to 2A square. In triangle ADF, triangle A, D and F. Here you see FD, it's a square diagonal, and AD, this angle is a right angle. Okay, so it's a right triangle. So in this right triangle, AF is its hypotenuse, FD base, AD perpendicular. So again, from Pythagoras theorem we know AF square, it is equal to AD square plus FD square. Value of AD, it's a h, so it is A square, plus value of FD, it is B square. But B square is equal to 2A square. So C square, it will be equal to A square plus 2A square. It's a 3A square. C is equal to under root 3A. It's a value of C. C means what? Value of AF. This AF is equal to under root 3A. But from figure again it is clear that this C means AF, it is equal to 4R. Why 4R? Again, this one is R, 4R. So AF is equal to 4R or C is equal to 4R. So we have two values of C, under root 3A and 4R. So you compare these two equations, 4R is equal to under root 3A or A is equal to 4 by root 3R. This is the value of A. So packing efficiency means number of atoms in body centered, number of atoms, B for body center, BCC, B for bi means 2. So number of atoms are 2. Volume of an atom, again 4 by 3 pi r cube into 100 divided by total volume of cell. Volume is equal to A cube, and the value of A is 4 by 3 or 4 by under root 3R. It means cube this one. So you solve this, you will find 68%. So it means the packing efficiency in BCC, it is 68%. So now quick revise the packing efficiency in three types of cubic cell. In BCC it is 68%, in FCC 74%, in primitive cell 52.4%. Remember these 3 points. Okay students, that's all for today's packing efficiency. Like and subscribe this video if you like it. Thank you.